There are, as you can imagine, a lot of great minds working on bringing down the cost of carbon capture. And the reason is not just for application in the United States. We're going to get a handle on our carbon emissions here, but around the world there are developing countries that are building coal plants. They need the energy to raise people out of poverty. We need to lead the way. We can't do it all by ourselves here in the United States.
This is Energy Cast, and I'm Jay Dowenhauer. Today we are talking about carbon capture and storage, the technique of making our most abundant energy source, coal, cleaner by scrubbing out its last remaining harmful byproduct, carbon dioxide. I was recently browsing Netflix and came across The Cloverfield Paradox, a film that takes place in the future where apparently energy supplies have dried up. Now, this wasn't 500, 1,500, 10,000 years in the future. It apparently takes place about 10 years from now. There were plenty of plot holes and gripes I could make, but the notion that the Earth will be bone dry of energy anytime in the near future is absolutely absurd. And coal, more than any of our conventional fossil fuels, has between 400 billion and 4 trillion tons here in the United States. So unless there is an outright ban on conventional energy, let alone renewables, we shouldn't fear a disappearance of energy supplies anytime soon.
I need to say 2 things that won't make sense to you.
Yeah, no kidding. Other than that, I give the movie 5 stars. I say all of this to make the point that coal, our most plentiful resource, does not get the due it deserves. It currently makes up about 30% of our energy production. That's about 4.5 times wind and over 30 times solar. It's reliable, affordable, and yes, clean. All the harmful pollutants are scrubbed out. However, it produces CO2. More so than other fossil fuels. You may recall episode 15. John Thompson of the Clean Air Task Force, one of the nation's leading environmental voices, said that
I just think that when you look at the math and you look at the reality of what we have to do, carbon capture just becomes essential to avoiding the worst aspects of climate change and to doing those reductions in an affordable manner.
That brings us to our guest today. Since December 2016, they have been successfully operating a commercial-scale coal-fueled carbon capture and storage facility. The venture is expensive, but profitable. To help the bottom line, they have partnered with an oil production company to take the CO2 they capture near Houston and pipe it to Texas oil fields to produce more oil. The process of injecting CO2 into oil fields to produce otherwise unrecoverable oil is called enhanced oil recovery. One of the trickiest parts of the process is the capture component, stripping out CO2 out of the coal plant exhaust or flue gas. In this case, our guests used a proven amine solvent process by which CO2 is absorbed and then released from the solvent by changing the solvent's temperature. It's highly effective. And rather than gasification, which is not nearly as common, this facility uses a post-combustion process for making power. Essentially, this boiler looks no different from any other coal-fueled boiler. I've unfortunately seen several carbon capture projects that were announced only to be slowly delayed and then ultimately canceled. And usually these projects were trying something never done before. The combustion process was unique. They were capturing with a new technology, or they were siting the facility in a location where water for boilers was difficult to procure. The lesson with my guest project is simple. This facility was successful because they went with what works. Everything was a proven technology. They are selling their carbon to a mature marketplace. The only risk, if you could call it that, was that all of these proven processes had never been brought together in a single unit. Once it's proven, efforts to gain efficiency and economies of scale then follow. Our guest today is David Greason, VP of Development for NRG Energy, and the facility he and others now call theirs is Petra Nova near Houston. The facility is a joint venture between NRG and JX Nippon Oil and Gas Exploration. It's the largest commercial-scale post-combustion carbon capture facility installed on an existing coal-fueled power plant. It generates 240 megawatts of power and captures 1.6 million tons of CO2 annually. That CO2 is sent via pipeline to a West Texas oil field where it is used for enhanced oil recovery. NRG says the production revenues have helped pay for the capture and make the venture profitable. I hope you enjoy my conversation with David Greason.
We're here with David Greason, NRG Energy. And David, we always used to hear there's no such thing as clean coal. What do you say to those folks?
Well, I say that there is such a thing as clean coal. We have built one in Houston, Texas, and it's up and operating. Now, it is expensive, and we acknowledge that, but we think that just like with the other green technologies, such as wind and solar, those facilities were built and those technologies were proven out, the cost came down dramatically. We think the same thing's going to happen with CCS.
And there have been a lot of CCS projects on the books. Many of them never even got to this stage. What do you think allowed NRG to succeed with Petra Nova when some of those other projects didn't make it?
For our project, and I can just speak for our project, I think our success is due to a lot of advanced planning. We spend a lot of time evaluating technologies. We spend a lot of time going through engineering of the facility we selected. We certainly started with a technology that had been proven at a somewhat larger demonstration scale, so we felt like the next step to commercial scale was going to be doable and successful. Another big part of why we were successful is our partners were all fantastic and committed to seeing this thing through, from the U.S. Department of Energy to the Japanese government through their NEXI and JVIC lending programs. The state of Texas was incredibly supportive and provides a lot of incentives for the project as well. Our Japanese oil company partner, JX Nippon, they are just a fantastic group, very resourceful. They contributed a lot to the success of this project. They didn't just bring money, but they were an active participant. And our oil field partner here in Texas has been extremely supportive. I think that everybody pulling in the same direction. We had a lot of advanced planning, and we were successful.
What has the team at Petra Nova learned since operations started?
The main thing that we've learned is that it does work and that it works very well. It's capturing carbon dioxide at well above the guaranteed levels that we were expecting. By well above, I mean we were guaranteed 90%, and we're definitely capturing more than that. I think also we've learned that the next copy of this technology that gets built probably can be done for at least 10%, if not 20% cheaper, just with some of the things that we've learned about how the system operates. You don't have to do certain things, and you could do other things better. I think we could see at least a 10%, if not a 20% reduction in the next one.
This came from a presentation that you did last fall. You're claiming that oil revenues pay for the entire project. How is that? Is that just carbon sales? What are the economics of that?
Our project structure is a little unique. We actually own not only the carbon capture system, but we own the CO2 pipeline, and we own the oil field where the CO2 is being injected. So literally, we capture carbon dioxide out of flue gas at the power plant, and our revenue is selling oil that's produced from the injection of CO2 into the ground. So it's a true statement. Oil revenues pay for everything.
So maybe it helps to be a little bit more integrated, I guess, in some of these cases, right?
In our case, it was essential to being economic, yes.
Yeah. And we've discussed carbon credits on this podcast in the past. Is NRG participating in any programs to help with the economics?
Well, we're studying that. At the time the project was constructed, the National Carbon Credit Program, otherwise known as 45Q, had an end to it, a limit on how much carbon could be claimed under that program. And so for our pro forma, we assumed that little, if any, of that was going to be available. But to answer your question directly, no, we have not claimed any credits or the value of any credits on this project yet. As you know, there was a recent bill passed that provided an enhancement to the 45Q program and takes away the limit that was set on it back when it was first passed. And so for future projects, we're certainly studying what can be done to structure the project so that we can qualify for those credits.
You say also there are no impacts on the power plant or its cost. Surely there's parasitic load, other things like that they're pulling from the power plant as it was.
Well, carbon capture takes energy. There's no doubt about that. The question is, where do you get that energy? And in our case, we elected to provide our own steam and power rather than draw that power and steam from the host coal unit. So we say there are no impacts on the power plant, and we mean it. That the host coal unit doesn't even know that we're there. The full output of that plant goes to the grid, as it always has, and we do not subsidize carbon capture with any of the cost of operating the host coal unit. We did that by building a gas-fired cogeneration system that's highly efficient, much more efficient at converting fuels into electricity and steam than just the boiler that we have for the coal plant. So by using a cogeneration system, we've actually lowered the carbon footprint of the so-called parasitic load, or the energy used for carbon capture.
You know, we see this a lot. Texas, great opportunity for enhanced oil recovery, and you're making the economics work by producing oil as well. Is there a solution for getting carbon capture and storage to work economically, you think, outside of zones where enhanced oil recovery is an option? For instance, I'm here in Charlotte, not a whole lot of oil production out here.
I think that you have to think about it in terms of how the industry will progress. As I mentioned earlier, the more carbon capture systems that get built, the cheaper it's going to be to capture CO2. Initially, yes, it's going to be better to do carbon capture in those areas where there's a reasonably close enhanced oil recovery opportunity. But listen, in Charlotte, you're not that far away in terms of pipeline distance from a very large CO2 pipeline that runs to Mississippi and portions of Alabama.
Yeah.
So you're not that far away effectively from enhanced oil recovery, at least by pipeline. Now, you know, the United States has extensive pipelines already set up. The idea of shipping CO2 by pipeline over thousands of miles is not that big of a technological challenge. It's already happening today.
Pipelines always bring us closer together, right? Carbon capture has always been an expensive part of the process, right? You said this earlier. You went with a proven process for capturing carbon, but what would you like to see on next generation CCS plants? Are there other technologies out there for capturing carbon that you see as being promising?
There are, as you can imagine, a lot of great minds working on bringing down the cost of carbon capture. And the reason is not just for application in the United States. You know, we're going to get a handle on our carbon emissions here, but around the world there are developing countries that are building coal plants. They need the energy to sustain their economies, to raise people out of poverty. We need to lead the way here in the Western world to try and see how we can get the cost down. And there are people doing that. For instance, we believe, and I think if you talk to the Department of Energy, they'll tell you they're real excited about membranes as an opportunity for separating carbon dioxide from flue gas. It promises to not only bring the cost down dramatically if it works, but also reduce the footprint. Many people think of coal plants as large pieces of real estate, and they are, but the actual usable area for these kinds of environmental control systems is pretty small. And so the smaller you can make these systems, the more plants they're going to be applicable to. There are solid absorbents out there that likewise promise to bring down the cost and dramatically reduce the size of the unit. So yes, there's a number of things on the horizon that we're excited about. I would hope that we'd see large-scale demonstrations of those technologies in the next 5 years, and following that, it should be off to the races to see how many of them we can build, how fast.
And I think it should be noted that the Department of Energy is putting a lot of money out there right now for these kinds of technologies, the carbon capture component.
I think they just announced funding for some of those next-generation technologies.
You talked a little bit about the international aspect. Do you think in some ways it might be easier to prove these technologies overseas?
I've spent my entire 37-year career here in the power industry in the United States. I know the ins and outs of licensing, of the electric markets, and how to do business in the States here. So for me, I can't imagine it being any easier than here in the environment that I know. But we've got to find a way to make it easy for other jurisdictions and other countries to adopt this technology. We can't do it all by ourselves here in the United States. Is it easier overseas? I'm sure that folks that live in China and do business in China will tell you they think it might be easier there. For me and my skill set, it was a no-brainer. This is the place to do it.
David, for years, the future of carbon capture and storage always seemed to be linked to gasification or IGCC. Do you still think that's the future, or is it more of a post-combustion process that you've proven?
We are technology agnostic. We're consumers of this kind of technology. We hope that the folks who have gasification technology figure it out and bring it to market, and we hope that it's successful. We think post-combustion might be the way to go as well. We certainly feel like they're further along at this point, but we're consumers of technology, and so we're cheering on as many of these technology developers as possible, because competition is the consumer's best friend, but as a consumer of technology, we want to have plenty of choices.
Rick Perry, former governor of Texas, long time. He's moved up to Washington. He's now Secretary of Energy. What kind of conversations have you had with Rick Perry, both before and after, I guess, his big move to D.C.?
I've had one conversation with the Secretary. I had the opportunity and the privilege to host him on a tour of the facility at the ribbon cutting in April of last year. He was very excited about this technology and about this project and asked a lot of really good questions. And then, of course, since his tour here, he has been talking about it a lot, about the Petronova project, in many of his statements when he talks about the clean energy future. And it's been nothing but supportive.
Yeah, this is really still pretty groundbreaking, been operations for a year. Let's flash forward. Let's look ahead 20 years. What role do you think carbon capture and storage plays in our energy mix in 20 years?
Here in the U.S., I think there are a number of coal plants that are economic in their markets, and you will see that those plants, as the CCS technology becomes more affordable, I think you'll see those plants with capture systems on them. Around the world, if we want to make progress toward reducing CO2 concentrations in the atmosphere, CCS has to be a part of that, and it just has to be successful. So I think the more that we can show here in the United States that the technology works and show that it can be economic and you can still provide all the power that your citizens and your economy need, I think the more it'll get adopted around the world.
Okay. Well, best of luck to you, and congratulations on so much success there at Petronova. We're all rooting for you and hoping to see many more just like you. And David, I'm going to finish here with a lightning round of your thoughts on different energy technologies. Natural gas.
Low cost and will be for the future.
Crude oil.
Lifeblood of the world energy economy and going to be for quite a while.
Nuclear.
The cleanest technology out there and hopefully becomes more affordable in the near future.
Coal in the larger sense.
Very abundant, needs a lower carbon technology.
And then CCS, you guys.
Expensive today, but promising in the future will be more affordable.
Wind.
Classic example for the CCS to follow. Expensive initially, but with enough support from the government, became affordable.
Solar.
Same thing. Initially very expensive, but today is coming very close to being competitive.
Biofuels.
One option out there, probably limited in scope.
Fuel cells.
Promising technology. Hopefully we'll get there soon.
Hydroelectric.
Probably the perfect source of electricity.
Geothermal.
Another very green and earth-friendly source of energy.
Electric vehicles.
Making progress and could be dominant in the near future.
Energy efficiency.
Always a good idea.
And then finally, nuclear fusion.
No earthly idea.
All right. David Greason, NRG Energy, thank you so much for your time.
Thank you, Jay. It's been a pleasure.
You bet.
That was David Greason, VP of Business Development for NRG Energy. CO2 from Petronova has boosted oil production from about 300 barrels daily to over 5,000, all while permanently sequestering carbon dioxide underground. The solvent used in the capture process was developed by Mitsubishi Heavy Industries and Kendai Electric Power Company. I was given a sample of that equipment years ago, and it still sits on my office bookshelf. It reminds me that, yes, there is such a thing as clean coal, and the effort to spread that technology is alive and well. I also want to thank David Knox with NRG for helping facilitate this interview. There are plenty of pictures of Petronova and helpful illustrations, which I've reposted on Instagram at Host Energy and online at energy-cast.com. All guests are sent the raw and completed program the week of release. So far, no complaints. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 31. Please join us us next time when we explore the emerging field of wireless power. Until then, I'm Jay Dowenhauer. We'll see you next time.